Let's look at polynomials of degree 4. Degree 4, x to the 4, and not, okay, if x to the 3 is a cubic, well, x to the 4 is a quartic. So quartic functions. So a fourth degree polynomial, not my highlighter, a fourth degree polynomial is called a quartic, and makes it fourth degree, we have x to the 4, okay? Now it's got a lot of the, in terms of sketching and translating the graph, it's very similar to that of our cubic and our quadratic. The quartic function of the form x minus h all to the power of 4 just shifts the graph to the left, shifts the graph h units and left or right, and k units up or down, okay? The basic shape of my quartic function is that of a parabola. So if you have a look at x to the 4 in there, I might just make it a bit bigger. If I was to draw x squared, the difference being, I won't draw it with that. An x squared graph, again, has a turning point there, but it's not as steep, if you like. I mean, it's a little bit, it gets steeper here. It's not as flat through the origin. So a quartic, if you like, has a sort of a flatter bottom about it, whereas the parabola is just a little bit steeper, okay, from that 0 to 1 section, or 0 to -1. But it's basically a similar graph to that of a quadratic if it's in the quartic function form. So it shifts left, right. Yes, that is a turning point in there at the origin. And depending upon whether our graph's been moved left or right or up or down, it shifts those. And so we can see here that our turning point is at hk if our general rule is given as x minus h to the power of 4 plus k. All right. So let's have a bit of a look. If I want to sketch the following, so my graph has been shifted 2 going on there. It's been shifted 2 units right and 4 units down. So let's make it 2 units right, we'll say there, 4 units down fits there. So there's my turning point. It's a positive quartic, so it's going to be like an upright parabola. Let's get a y-intercept. We'll put x equal to 0, and I get y is equal to 0 minus 2 to the 4 plus 4. So -2 to the 4 is 4 by 4, which is 16, plus 4 is 20. So it's quite a long way up here. So clearly from that then, I'm going to come down. I might just try and make it a little bit flatter through there. And it goes up. Yeah. So we'll call that point there at 20. What I can see though is I've got a couple of x-intercepts. So to find my x-intercepts, I put y equal to 0. 0 is equal to x minus 2 to the 4 minus 4. Take the 4 across. And I'll write that as 2 squared, because I'm now going to work out the 4th root of that. And from my index laws, I know that's the same as 2 to the power of 2 on 4, which is the same as 2 to the half, or the square root of 2, which means x is equal to 2 plus or minus root 2. Mr. Gale, you forgot to put the plus or minuses in. Because as soon as we take an even nth root, so the square root, the 4th root, the 6th root, we always get a plus or minus. So that's clearly going to be a 2 plus root 2 there. 2 minus root 2, give some thought, minus root 2. So root 2 is somewhere between root 1 and root 4, which makes it somewhere between 1 and 2. So if I subtract that from 2, I'm going to get a positive answer. All right. And we should label our turning point to -4. Okay. Similar. Now, a couple of things we need to do. Let's rewrite it in. Let's get the negative sign there. I'm going to take that 2 out the front and write x plus a half all to the 4 plus 16. All right. That makes it really clear what sort of a translation left or right I've had. All right, so write your coefficient of x as +1 all the time. Negative out the front means I'm going to be upside down. The positive a half inside is going to translate to the left half a unit, and obviously the 16 is going to move everything up half a unit. So we know that that turning point is going to be at negative a half, which we might make that point there, positive 16. So my scale is going to be a fair bit out, isn't it? So let's just make that point 16 there. So we'll go with negative a half, 16. And let's get some intercepts. So if I put x equal to 0, y is equal to negative 2 times 0 plus a half plus 16, which is equal to negative a half to the power of 4 is 1 over 2 to the 4, which is 1/16 times 2. So that's 2/16, negative 2/16, with the negative out the front, plus 16. So what's that? 16th and 1/8. So we'll call that 15 and 7/8. So just a little bit less than that. We'll find our x-intercept, so put y equal to 0. So I'm going to have, even if I start with the original function, I'll have 0 is equal to 16 minus 2x plus 1, oops, to the 4. So therefore we get 2x plus 1 to the 4 is equal to 16. If I take the 4th root of everything, that's going to be the same as 2 to the 4 to the 1/4, which is just 2, so plus or minus. So 2x plus 1 is equal to plus or minus 2. 2x is equal to subtract 1, plus or minus 2 minus 1. So what's that mean? So I'm going to get 2x is equal to positive 2 minus 1, which is 1, negative 2 minus 1, which is negative 3. So x is equal to 1/2, or negative 3 on 2. So positive a half. So obviously they're both pretty tight. So we'll call that positive a half there. Negative 3 on 2 maybe over here. And we'll just go a bit flatter through there and down through there. Okay, so we'll label our axes. Negative 3 on 2, 0. A half, 0. I guess the key thing to note, if that's at negative a half, my turning point is still in the middle of my intercepts. So that's just a nice little check. And our y-intercept up here at 0 and 6, was 15 and 7/8 or something. Yeah. All right. So that's our quartic function if it's in the quartic form.